Good morning or good afternoon from wherever you may join. My name is de Klerk Wenzel. I'm a Senior Product Manager on the AWS DeepRacer team, and today we're going to talk about getting started with AWS DeepRacer. I have with me Brian Townsend, who's our Senior SDM on the project. So let's get started. So on the agenda today is we are going to be talking a bit about DeepRacer, just a brief overcap. I don't know if you recall the webinar we had in December. We're going to talk a bit about reinforcement learning and focus on the virtual simulator and the console, and then show you how you can get involved. So before we get started, let's just do that quick recap on AWS DeepRacer. So at reInvent 2018, we launched AWS DeepRacer. AWS DeepRacer is a 1/18th scale robotic car which gives you an exciting and fun way to get started with reinforcement learning by applying it to autonomous racing. You can pre-order your AWS DeepRacer from Amazon today. Now, AWS DeepRacer also has a virtual racing simulator that allows you to train, evaluate, and iterate on your reinforcement learning models in a racing environment quickly and easily. And if you get really good and want to showcase your machine learning skills in a competitive environment, there is the AWS DeepRacer League, where you'll be able to compete in a global championship, racing your DeepRacer model for a chance to win several prizes and advance to the AWS DeepRacer Championship Cup. Throughout 2019, there will be in-person events at selected AWS summits and a series of virtual competitions hosted in the virtual simulator, giving all developers the ability to compete. So let's take a quick drive through what is reinforcement learning. The idea around which reinforcement learning is built is used quite often, perhaps daily, by humans. Think about the last time you used a reward to incentivize the right behavior. A simple example would be, how do you train a pet? Treats are typically used to incentivize the desired behavior. Training can be for simple actions like sitting or staying, and can move on to more complicated series of behaviors, like what you would sometimes see in dog agility competitions, crawling through tunnels, jumping over hurdles, and weaving through poles. So what is reinforcement learning? Reinforcement learning is a branch of machine learning interested in the creation of a model that can be used by an agent to choose which actions to take in an environment in order to achieve a specific goal. In the AWS DeepRacer simulator, the agent is the virtual car. The environment is a virtual racetrack, and the actions are throttle and steering inputs to the car. And the goal is completing the racetrack as quickly as possible and without deviating from the track. Our model needs to learn the desired driving behavior to reach our goal of completing the track. And just like with pets, we will use rewards to incentivize our model to learn that desired driving behavior. Let's take a practical look at how we can use reward functions to incentivize driving behavior. On screen, you'll see a small grid track example. The blue square is where our car will start, and the green square indicates the goal. The car can move to every other square except the purple ones, which are out of bounds. Each square is called a state, and our available actions in each state is to move forward, backward, left, or right, with the car always facing in the direction of the goal. A simple solution for our car to reach its goal would be to always stay in the center of the track. We can incentivize the car to learn this driving behavior by providing higher rewards when its actions keep in the center of the track and lower rewards when its actions go elsewhere. You may ask, why will this make the model learn the behavior? So reinforcement learning algorithms are geared for optimization of cumulative rewards. The model will learn which action and then subsequent actions results in the highest cumulative reward on the way to the goal. That is, it tries to forecast what is the total reward that I will receive if I go down this action. So learning doesn't just happen in the first go. It does take some iteration because our model first needs to explore and see where it can get the highest rewards before it can turn to exploit that knowledge. So how does that iteration take place? As DeepRacer drives around the simulated racetrack, it takes around 10 pictures per second. These pictures represent states of the environment, and the agent uses the combination of state and the model to determine which action to choose. When training begins, the model will select actions at random because the model really doesn't know anything, and so it will explore the environment. For each state and action, a reward will be received and the car will obviously be in a new state. The reward that the car receives is determined by the reward function, and this quantifies how good or bad the outcome of a particular action is. One such state, action, reward, and new state loop is called a step, and all the steps from the start state, this is where the car resets, to the next terminal state, such as finishing a lap or crashing off track, is called an episode. After a set number of episodes, the experience obtained will be used to update the model. This is kicking off a training job that trains the weights in the model. And then we will restart this exploration process with a new and improved model to collect more experience, and this will subsequently be followed by an additional training job. During training, the model learns which actions to choose in each state based on the cumulative rewards that can be obtained from that state onwards. The model tries to maximize that cumulative reward. We want our model to explore the world initially because if it starts exploiting new knowledge too fast, it could get locked down in a path that is good, but perhaps not the best path. And this would be very short-term decision making, whereas reinforcement learning is really focused on long-term optimization. So you determine typically how soon your model should start exploiting the knowledge. And if you exploit too soon, you forgo finding the better action. However, if you explore too long, your model will likely take a very long time to train. Once your model is trained, you have a value function. And that is a function that knows what the expected cumulative reward is for all actions from a particular state. Simply selecting the action with the highest value in the value function will give the best outcome. And this mapping from state directly to action is called a policy function. So if you think back to our grid example, it's very easy to explore the whole grid and build this value function and then also obtain the policy function. You can simply build a lookup table. But for many reinforcement learning problems, the domain is so big that it's almost impossible to explore every state action combination. So how would we know what the value function is for each action in a state if we've never been there? Here we're going to look at one way, and this is what AWS DeepRacer uses to train a reinforcement learning model. You can't explore all states and action combinations. So what you would need to do is you would need to approximate what action you think you should take. And the way that this is done is typically by using supervised learning to train a policy function model that returns the best action from any state. And this is done using the experience that the car obtains. The method that DeepRacer currently uses is called PPO, or Proximal Policy Optimization. For the remainder of this talk, we will be focusing on the virtual simulator and what you should expect when building your reinforcement learning models. Just a quick warm-up lap before the race starts. As you start training a model, the following happens. DeepRacer uses step functions to start an Amazon SageMaker container and an AWS RoboMaker container in your service account, and it links the two. It then passes the right parameters to start the training, and as the model trains, the outputs The models, video, and metrics are stored in other AWS services in your account. And by logging into each of these services, you'll be able to see the data created from your DeepRacer training jobs. This diagram gives a quick overview of all the activities you can do in the console. And we're going to be focusing on creating and training a model and pay particular attention to the reward function, as well as look into how you evaluate your trained model and potentially iterate on that model. This is a preview of the AWS DeepRacer console, showing you a list of the models I've trained in the virtual simulator. I can select each of these models to clone, evaluate, download, or delete it. And I can also create a new model. And since we really want to focus on the reward function, that's a good place to start. So let's go and click Create Model. AWS DeepRacer was designed to abstract away the heavy lifting, but still provide enough information to get started with reinforcement learning as quickly as possible. We placed handy information buttons throughout the console to give you a quick info update on what this particular item pertains to. And if you wanted to go further, you can always go into the DeepRacer developer documentation or post a question on the AWS DeepRacer forum. Today we will create a reinforcement learning model that uses the basic reward function. So let's just give our model a name. This is going to be a reinforcement learning model that we train using the basic function for about 120 minutes, so 2 hours. As you can see here, there's a permissions and storage section, and this just calls out the fact that to use the DeepRacer service, you will have to create certain IAM roles, and we'll do that on your behalf. But this links back to what we just discussed, where we use the step functions to call SageMaker and RoboMaker on your behalf. Now, if we scroll down, we get to this space called Environment Simulation. And this shows the simulated environment on which you will train your reinforcement learning model, otherwise known as the track. So what you would do here is you would select the track that you're going to train your model on. And what I'll do next is I'm going to jump into some of the track components. So here I'm showing you a breakdown of the track components using a first-person view of the car as it drives down the track. You can see in the top right-hand corner, this is where our car is positioned on the track. And I've enlarged the car a bit just so you can clearly see where it is on the track. So we have a track wall and a field. When your car drives on the field, that is considered off track. And you should see your car resetting onto the track. We obviously then have the track surface, and this is basically on track. And we have track boundaries, the two white lines on either side of the track. These are quite important because once your car crosses the boundaries, it'll be reset onto the track. And we also have a yellow dotted line in the center of the track. These components are important because we can use them to help determine whether an action resulted in a good or bad outcome. And there are a few other components we should also look at. And that is the coordinate system and track waypoints. This is a 3D environment, so it has an X, Y, and Z axis. For simplicity, I'm not showing the Z axis. The waypoints are spread around the track and typically stipulated in X and Y coordinates. However, we can connect them with a line, and then we have a precise center line of the track. The waypoints help us to programmatically determine how much of the track DeepRacer has completed, or track progress. And it can also be used to tell us how far DeepRacer is from the center of the track. And this can be very useful when determining whether DeepRacer has actually left the track or not, because once we know the center of the track and the width of the track, we can simply back out, is DeepRacer still on the track or not, using its XY coordinates that we get back from the simulator. The waypoints are also used to indicate what is the direction of the flow of the track. And we can go one step further and actually determine what is the direction from one waypoint to the other. and use that as an additional input feature in our reward function if we so wanted. We also have the car yaw, and this is the direction of DeepRacer with respect to the x-axis in our simulation environment. All of these track components and track waypoints are important because after every action in the state, action, reward, new state loop, they are variables that we can use to build logic to determine whether an outcome was good or bad. And that is used to incentivize the right driving behavior. Also important to call out here and reinforce it, mind the pun, is that since this feedback loop only exists in the virtual world, training can only happen in the virtual world. There is no feedback loop in the physical car to help it determine whether an action was good or not. I guess for those hackers out there, if you wanted to, you can try and put something together with a buzzer that you press as soon as your car does something bad, but it's not something we've done in our experiments yet. Let's scroll down to the reward function. As mentioned before, the reward function is a pretty integral part of training our reinforcement learning model, and we've provided the ability for you to program in Python 3 syntax your own reward function. We've also given you the ability to validate the code that you've written, and we've provided 3 reward function examples. A basic function that you can select and just click insert code to copy the code across, and 2 advanced reward functions. And we'll look at one of those a bit later. But let's dive a bit deeper into the reward function code. So our reward function has the typical function headers, and this shows the variables that will be calculated after each action is taken in the simulator. There's on track, X, Y, distance from center, car orientation, progress steps, throttle and steering, track width, waypoint, and closest waypoint. We didn't cover throttle and steering in our previous slide, so let's pay particular attention to those quickly. Throttle is just what is the current speed on the motor of the car, or what is the speed taken during the action. And steering just indicates what is the angle that was sent to the servo. We've spoken about the other items, so let's see how these variables can now be used to try and build that logic to help us incentivize the right driving behavior. Here we have an example of center line following. So we want our car to stay as close as possible to the center line. And if you think back to our grid example, it was basically saying, I want you to drive down the center line, and as such, I will give you a higher reward if any of your actions lead you to drive down the center line. So in order to do this, we're going to create 3 markers, and this is essentially like dividing the track into bands. We're going to use the track width, and we're going to say, let's say 10% of the track width, that's the first band. 25% of the track width is the second band, and 50% of the track width is the third band. So how do we use this to build that logic of ours? Well, we can say that if the distance from the center of our car is greater than 0, but it's less than that first band, that 10% of the track width, we can give a reward of 1. If it's a bit further out, but still within the second marker, we can give a reward of 0.5. And if it's even further out than that, we can just say the reward is 0.1. And if it's way beyond that, we can say the reward is a really small number. And I'd like to just focus on that a bit. The reinforcement learning algorithms that we use are pretty sensitive to rewards being 0. So rather initiate them as small numbers as opposed to just using 0. And then after every step, what's going to happen is this reward function will be called, and it'll evaluate the code, determine what is the reward that should be given using those track components and the variables from the simulation environment, and that'll return the reward. I have to also call out that this reward function is stateless. So you can't see what the variables were in a previous step. You can only see the current step. So let's jump back into our console. We have our code in here. We can click validate, and that'll just show us that your reward function has passed validation, which is great. Now let's scroll down a bit and look at what happens when we start training. For today's session, we're not going to dive into the algorithm settings. These are the various hyperparameters that control how reinforcement learning takes place. Just an interesting one to call out would be the number of episodes between each training. I place particular emphasis on the fact that after a set number of episodes, training starts, and here this is where you would specify this parameter. These parameters also determine how much you explore versus exploit, what your learning rate is, and a few other typical deep learning attributes. So we'll be specifying our stopping condition. I'd like to just call out here that it takes about 6 minutes to spin up the SageMaker and RoboMaker containers. So if you want to train your job, try not to specify something like 10 minutes or 15 minutes because in reality your model will not have enough time to really learn anything. It needs a decent number of training iterations before it can really, give good results. So what I'm going to do is I'm going to specify 120 minutes because that's what we said we'll do. And then we'll kick off the training. Now, I've already trained this model using this exact same parameter set. So I'm going to scroll back into my reinforcement learning list. So I started a basic model a few minutes ago, and let's see how that is progressing. On the screen, you will see training and what is the cumulative reward per episode. You will also see a video showing what is happening in the car space. And you will see the stopping condition specified, the evaluation, and we haven't done any evaluations because our model is still training. And then also the configuration. What were the specific parameters and reward function used to train this model? So you'll see the hyperparameters, the framework we're using, what is the algorithm, it was PPO, and this is our basic reward function. So in the simulation, initially you will see the car driving off track quite a bit because the model doesn't really know anything. So it's randomly trying actions and seeing what the resulting rewards are. And once it has built up 20 episodes of experience, you should see your car aimlessly wandering off and potentially hitting a wall. And the reason for that is the simulation has now passed the data back to SageMaker, and SageMaker is starting to train that model. And as soon as the model is trained, it'll send it back into a virtual simulator being run in RoboMaker. And then the car will reset on the track and it will start collecting additional experience using the new model. This reward graph shows you what is the cumulative reward per episode received. So expect it to fluctuate wildly, as I said initially, because there is a lot of exploration going on. And we want this to go up and to the right. And this is typically what happens when we start training our model. Let's go back and look at what you should see in a trained model. We've trained our basic 120-minute model. And you should see a message at the top saying training completed and a green button there. And once you've done that, you can come and you can run the evaluation by just clicking Start Evaluation. I've already run an evaluation. And what it essentially tells us is I've run 5 trials around this track. And this is my trial results. On the first lap, I completed 100% of the track, and it took me 1 minute 26 seconds. In the second lap, it failed, and it only completed 46%. And then on the subsequent laps, it actually completed the track. Well, you can see the times are a bit, there is some variance in the time. So what we want to do is we actually want to go and see, is there a way that we can improve this reward function that we used? And so typically you would look at the video of training. You can even download the model onto a car and see how it performs in the real world. But let's go and have a look at if we wanted to clone this model and use a advanced reward function. So we're going to go into advanced reward function and we're going to select the first item here. And this is basically, you'll notice the same structure that we had before where we had our header. We had a bit of helper code here, the logic that went into it, and in this instance, we're adding an additional feature into our logic. We're basically saying that our car because it's taking 10 pictures a second, and essentially it can, decide to go left, right, there is some sense of control theory here, and that the car can go from left and to right quite a bit, and that will obviously, it'll keep it on track, but it'll decrease the time, or sorry, increase the time that it takes to complete the lap. So what we want to do is we want to go and penalize steering. Steering is something that is specified from -1 to 1. And let's just look at 0 to 1. 0 is basically there's no steering. 1 is the maximum steering, in this instance to the left. If our car steers more than 0.5, we actually want to go and reduce the reward. So we want to disincentivize that excessive steering. And the way that we can do this is simply by putting in a multiplier on our reward. So we can say, if your steering is greater than 0.5, the absolute steering that is, just multiply the reward by 0.8. And this should incentivize our car not to do excessive steering. The risk here is, as soon as you start incentivizing certain behaviors, there's always an opposite side to the story. If your car is really afraid of making sharp turns, then obviously some turns like the hairpin or the reinvent track, your car will not be able to make. So excessively penalizing those things are not advised. Certainly you can experiment with them. We've experimented with a lot of these. In some instances, our scientists have run, tens of experiments just tweaking some of the reward parameters, adding additional things, for example, saying what would happen if we penalize the throttle, doing some combination of throttle and steering, looking at potentially backing out from waypoints, closest waypoint. What is the direction of the track? And then rewarding the car if the car orientation or car yaw is the same as the track orientation. So we've experimented with a lot of things, and I think the biggest tip we can provide here is probably start simple. Start with the initial basic function. See if you understand how it works. Train it, evaluate it, and then you start iterating to see if you can get better lap times on your car. So that's a brief overview of RL and the console, and with a particular focus on reward functions. Let's wrap up with a quick discussion of how you can get involved. So how can you get involved? Pre-order your AWS DeepRacer now on Amazon.com by just searching for DeepRacer, or you can sign up for the preview access to the AWS DeepRacer console on the link on screen. Lastly, go and explore the Amazon SageMaker RL notebooks. We've provided a tutorial, that's the pink tinyurl link, and that should take you to a tutorial on how to train AWS DeepRacer reinforcement learning models using SageMaker directly. Finally, the AWS DeepRacer League will officially kick off in 2019 with an online experience for everyone and physical events at selected locations co-hosted with AWS Summits. So stay tuned for more information on that, or go to the link at the bottom of the page. Train your models now, get them ready to race, and you can submit them via the console to our online leaderboards, or download them and bring them to AWS Summits to compete. Winners of each of these stages, online and in person, will progress to the DeepRacer League Cup at reInvent 2019, where we can see if you have what it takes to lift the championship cup. So I'd like to thank you very much for your time today. Thanks for joining us. I hope you enjoyed the brief tour through the console, looking at how you would grade your models, and specifically looking at the reward function and what the different parameters and variables mean. Please feel free to reach out to us if you have any questions, and we'll now take some questions. Thank you.